Welcome to this comprehensive tutorial on the Blowfish encryption algorithm in Java. In this video, we will explore the intricacies of the Blowfish algorithm implemented in our Java applications and understand its significance in encryption. Before we dive into coding, let's first understand what the Blowfish algorithm is. Developed by Bruce Schneier in 1993, Blowfish is a symmetric key block cipher that operates on 64-bit blocks and supports key sizes ranging from 32 bits to 448 bits. It's known for its speed and effectiveness, making it a great choice for secure data encryption. Now, let's set up our Java environment. If you don't have Java installed, please download the latest version from the official Oracle website. Make sure to set up your IDE, such as IntelliJ IDEA, Eclipse, or NetBeans. For our implementation, we will use the Bouncy Castle library, which provides support for the Blowfish algorithm. To get started, we need to add the Bouncy Castle dependency to our project. If you are using Maven, you can add the following dependency to your pom.xml file. With the dependency added, let's explore how to encrypt a simple string using Blowfish. First, we'll create a utility class called Blowfish Encryption. This class will contain methods for encryption and decryption. In the code snippet above, we first import the necessary classes from the Bouncy Castle library and the standard Java API. We then define our Blowfish encryption class and set up the Blowfish algorithm constants. The encrypt method accepts a key and the data to encrypt, initializes the cipher in encrypt mode, and returns the base 64 encoded encrypted string. Next, let's add the decryption functionality to our Blowfish encryption class so we can retrieve our original data after encryption. The decrypt method is similar to the encrypt method. It initializes the cipher in decrypt mode, decodes the base 64 string, and returns the original data as a string. This creates a complete cycle of encryption and decryption using Blowfish. Let's put our Blowfish encryption class to the test with a simple main method. This will allow us to see it in action by encrypting and then decrypting a sample string. In the main method, we define a secret key and some data. We call our encrypt method to encrypt the data, print the resulting encrypted data, and then use the decrypt method to get back the original data. Let's run this program and observe the output. As the output displays, you will see the encrypted representation of "Hello, Blowfish," followed by the original message upon decryption. This confirms that our Blowfish implementation is working correctly. Next, let's discuss the key strength and security aspects of the Blowfish algorithm. Blowfish is known for its variable length key feature, making it resilient to brute force attacks when using sufficiently long keys. However, it's also important to handle key management practices correctly to maintain security in your applications. In real-world applications, you might want to consider additional best practices such as 1. Using unique keys for different sessions to prevent key reuse. 2. Regularly changing encryption keys. 3. Implementing authentication to ensure data integrity. Moving forward, let's consider the scalability of the Blowfish algorithm. Blowfish works extremely well for applications that require fast and efficient encryption and decryption of data. Blowfish is suitable for a variety of applications, such as encrypting sensitive user data in a database, securing communication channels, or protecting data in transit through cryptographic protocols. Let's now assess the limitations of Blowfish. Despite its advantages, Blowfish has a few downsides, one of which is its 64-bit block size. As technology evolves, this block size has become less secure against specific attacks. If you're working with large amounts of data, you might want to consider a more modern encryption method, such as AES, which utilizes larger block sizes. In conclusion, we have successfully implemented the Blowfish encryption algorithm in Java using the Bouncy Castle library. We explored how to encrypt and decrypt data as well as discussed key management and possible applications. Thank you for watching this tutorial. If you found this video helpful, don't forget to subscribe to our channel for more programming tutorials. If you have any questions or suggestions for future topics, please leave them in the comments below. Happy coding!